Today we are in lesson 5.6, the last unit in the last lesson in unit 5. Yesterday we looked at law of sines. Today we're looking at the law of cosines. And to develop that, I've got the picture cut and pasted from your book. We're looking for this length right here, which is a, and I can use the distance formula to find that, which is subtracting the x's, that is x minus c squared, and subtracting the y's, which is y minus 0 squared. In here, they've given us some trig equations. I'm going to solve this. X is equal to b cosine of a, and here y is equal to b sine of a. So I'm going to take those values and substitute them in. We've got then b cosine of a minus c squared plus b sine of a minus 0 squared. And we're just going to simplify this up. So inside here, I'm going to go ahead and FOIL this out. That gives me b squared cosine squared a minus 2bc cosine of a plus c squared. Over here, we've got b squared sine squared a. And remember, this is ultimately our goal in terms of what we want it to look like. So first thing, if you notice in here, if I factored out a b squared from each one of these, I'm left with cosine squared a plus sine squared a, which we know is just plain old 1. And then we've got plus that c squared minus 2bc cosine of a. So again, this cancels out to just plain old 1. If you look here, b squared plus c squared. So we've got b squared plus c squared minus 2bc times the cosine of a. And again, certainly not expecting you to do that on your own, but it's just exposure to some of these proofs. Here is that formula that you saw back in geometry for the law of cosines. Again, the question is, when are we going to use this? First of all, we are using this for non-right triangles. And there are two cases when we're going to use this one as well. Zoom in a little bit for us. So those two cases are when we have two sides and the angle in between them, which is side, angle, side, and all three sides, which would be side, side, side. Now, if you think back to yesterday when we did law of sines then, that was the case where we had two angles and a side, or we had two angles with the side in between them. So that kind of breaks down to when are you going to use the law of cosines versus when are you going to use the law of sines. So let's go ahead and take a look at how this one works. Also up here, I'm just noticing same process we talked yesterday. Little a, b, and c represents the sides, which means big A, big B, and big C represents the angles across from those sides. Taking a look at number 1 and reading through it, and the picture we've already been labeled with all of the given information. If I take a look at this, this is side, angle, side. If I tried to set up law of sines, I wouldn't be able to. So again, you don't have a choice. If you tried to set it up, it wouldn't work, so that means I'm using the law of cosines. So let me put that formula out. A squared equals b squared plus c squared minus 2bc times the cosine of a. The main thing is whatever angle you have here, the side across from it that corresponds goes out here. In this particular case, we've got 3.5 is our b, 2.5, and the order doesn't really matter there. 2 times 2.5 times 3.5 cosine of 40 degrees. The nice part is I get to plug all of that in directly into my calculator. When I do that, you should get a squared equals 5.09. I take the square root, and I get 2.3 miles. Okay, just wanted to quickly show you, I typed in exactly what I saw that I had on my paper. I get 5.09. Just make sure you take the square root. Okay, the second case is when you're looking for the angle. Going to be a little bit more complicated, but not too bad here. We've got lengths of 10, 14, and 15, and we are looking for the angle across from the largest side. That means I'm looking for this angle here. I'm just going to label it to be angle A. Plugging into that same formula, as I said, if this is the angle I'm looking for, the side across from it has to go out in front. In other words, I've got 15 squared needs to go out in front. Substituting everything else, and we've got cosine of A. I need to go and solve for the cosine of A. Now, many times what you probably did before, you squared this, you squared this, you squared this, you added them together, and then subtracted. I'm going to suggest we can do all of that in a single step. So I'm squaring each one of those, and I'm subtracting each of those from that 15 squared. And then on the other side, I can multiply everything together. So plugging all that in, I have negative 71 equals negative 280 cosine of A. We want to get the cosine by itself, so we're going to divide by negative 280. We get cosine of A is equal to 0.25. Anytime we're looking for that angle, we know we need to use the inverse button. So we've got the measure of angle A then would equal inverse cosine, and we can use that answer key button as well. Plugging that in, I end up with 75 degrees for the measure of this angle. Now, some of your problems tonight might say solve. That simply means you want to go and find the other angles and sides as well, whatever information is missing. So if I wanted to go find this angle, I would have to repeat this process, only 14 would be sitting out in front instead. All right, final piece. Yesterday we looked at one way to find the area of a triangle. It is on your formula sheet. That was the 1/2 AB times the sine of C. Today we're looking at one other one, and this one we're not going to show you where it came from. We're just going to show you how to use it. The biggest thing here is there's something called the semi-perimeter. That just means half of the perimeter. So remember, the perimeter means the distance all the way around. So if I had little a, little b, and little c, I add all those up, I divide by 2, and this is called Heron's formula. Notice you take the semi-perimeter and subtract each one of your sides, multiplying it by the semi-perimeter, and then eventually taking the square root. So let's write down a few things. S is the semi-perimeter. And again, little a, little b, and little c are equal to the side lengths. And then finally, back in geometry, is the triangle inequality theorem. It says the sum of any two sides has got to be larger than the third side. So let me give you an example. If we had 5, 6, and this was 8, I have to check that 5 plus 8 is greater than 6. It is. I'd have to check that 8 plus 6 is greater than 5. It is. And then finally I'd have to check that 5 plus 6 is greater than 8, and it is. The quickest way to check this is really add the two smaller and make sure it's larger than the third side. So if we look at number 3, we want to make sure that a triangle even exists. It does. If I add any two of these, it's larger than the third. And then we're going to go ahead and find the area. And you might be saying, why can't I use one of the other ones? Well, if you think about the information that you have on this particular one, we have 13, 15, and 18. I could drop in the height, but the issue is I don't have another angle. So this allows us to find an area without knowing any angle measures. Let's go find the semi-perimeter first. So we're adding up all the sides, We are dividing by 2. I end up with a semi-perimeter of 23. So plugging in, we've got S, and then we're going to take that semi-perimeter and subtract each one of the sides. Our semi-perimeter was 23. Let's try and do a little bit of math in our head. 23 minus 13 would be 10. 23 minus 15 would be 8. 23 minus 18 would be 5. Plugging that in and taking the square root, I get 95.9 units squared. Now you might be saying, could I go and find that angle? Well, you could using the law of cosines, but that means you've got to use that formula that we just did at the top. Certainly this option is less work. If you remember the other option, you can still use that to find an angle, drop in your height, and ultimately find the area as well. Looking at the last one, find the area of the triangle. Well, the first thing I want to check is that triangle inequality theorem. Notice when we add 5 plus 6, it is not greater than 12, which means no triangle exists. And if I can, let me just get you to think about it. If this was 12 and I had a little guy here was 5, and I had another segment here that's 6, these two sides together have got to be greater than 12. If they're not, then that means when I would lay those segments down, they are literally lying right on top of the 12. So it has to be just a little bit greater, if you can envision, to get those sides to pop to actually form a triangle instead. All right, that is it for your notes. You're going to get all of these formulas. If you notice, they are the last few formulas that we're covering. I'll just point those out on your gold sheet. They are, here's the law of sines, here's the law of cosines that we talked about. Here's the 1/2 AB sine A area formula, and here's Heron's formula to find the area as well. As always, if you have any questions, please send me an email. We will try and get those cleared up. I'll be checking throughout the day. And then for tonight, you also need to make sure that 50% of the Math Excel is completed by midnight in order to be counted present. Thanks so much. Enjoy your weekend.